Alrighties, hello everyone and welcome to your pre-lesson video today on quadrilaterals. So let's get right into it. So first thing we are going to be going over today are properties of parallelograms, alright? So a parallelogram is a quadrilateral that's opposite sides are parallel. So as you can see from this example image, this side and this side are going to be parallel with each other. And they're actually also the same length, so they're congruent, right? And then this side and this side are parallel with each other and they are congruent, like you can see. So if a quadrilateral is a parallelogram, then its opposite sides are congruent. So this and this are congruent, this and this are congruent, and this parallel, this parallel. All right. Now another thing also with a parallelogram is that its opposite angles are congruent. So this angle and this angle would be congruent because, as you can see, because of the parallel lines, they cause a Z shape in the armpits. And that's why the opposite angles will be congruent with each other. So like this one, angle D is congruent to angle B and angle A is congruent to angle C. Alright? Now another thing also is that if a quadrilateral is a parallelogram, then the diagonals bisect each other. Can you see that? The diagonals, when they bisect, they will meet at a center here, and as you can see, the lines, the diagonals of each other bisect the other. So like this and this are congruent, this and this are congruent. Alright, so if you have any questions about these, bring it to your deep dive lesson. Alright, so now on to our last property of a parallelogram is that a diagonal of a parallelogram, so this thing, divides the parallelogram into two congruent triangles. So you can see it got bisected, or sorry, it did not get bisected, but the diagonal, bisects a parallelogram, and so this is a triangle and this is a triangle, right? And they're both congruent, as you can tell, because of the ASA. Alright? So yeah, a diagonal of a parallelogram divides the parallelogram into two congruent triangles. Alright, now we'll go into more parallel line theorems. So if two or more parallel lines are cut by two transversals, then they divide the transversals proportionally. So if we look, we have transversal S and transversal T. We have parallel lines L, M, and N. Alright, so look, if L is parallel to M is parallel to N, then that means A over B would equal to C over D. They are proportionate to each other. Their ratios would be the same. Or we could also say that A over C would equal to B over D. Alright? So this is really handy because of a few questions that we will see in the deep dive lesson that plays around this. Alright? Now, if a line intersects the midpoint of one side of a triangle and is parallel to another side of the triangle, then it intersects the midpoint of the third side of the triangle. So we look, we're taking line AB and its midpoint is going to be X, right? So that means this line is going to be bisected, AB, by X. Right? And we know that XY is parallel to BC, which means Y would be the midpoint of line AC. Alright? Now, if a segment joins the midpoints of two sides of a triangle, then the segment is A parallel to the third side of the triangle and B half the length of the third side. So let's look. If X is the midpoint of line AB and Y is the midpoint of line AC, then line XY is parallel to line BC and XY is half of BC. Alright, and we actually will see a question something like this in your deep dive lesson if I'm not wrong. Alright? Now, if you have any questions about the parallel line theorems, again as usual, send me a message, email, or bring it to your deep dive lesson. Okay. Now, with rectangles, rhombuses, and squares. So essentially, rhombuses, rectangles, and squares are special cases of parallelograms. Alright, just because remember, if we look at the definition of a parallelogram, it's a quadrilateral that's opposite sides are parallel with each other. Okay, so we look, this side and this side parallel, this side and this side are parallel, 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 parallel. That's why these are special cases of parallelograms. Alright, so just remember, a rhombus is a type of parallelogram where each side has the same length and opposite angles are equal. So this and this, this and this would be the same length, and then their opposite angles all here. Oh, sorry, this angle and this angle will be the same, and this angle and this angle will be the same. Alright. So now, with rectangles, rhombuses, and squares, these are some of their properties that are really, really handy to remember. So the diagonals of a rectangle are congruent, which means this line, so AC, would be congruent to BD. Alright, and they will meet at the very center of the rectangle. Now for rhombuses, the diagonals of a rhombus are perpendicular and bisect the angles of the rhombus. So if we look, if they cut each other, look, the diagonals meet each other perpendicularly. And if we were to, bisect it, the angles would be bisected nicely in half. Here again, these would be the same. All right. Now, the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. So essentially what this means is, if we were to draw diagonals for a square, right, it would look like a right angled triangle because of the right angle here. So this is the hypotenuse. Now what essentially this statement means is that from here, the midpoint, E, right, it'll be equidistant from D, A, and B. So that's why EA would equal to EB would equal to EC and ED. Now we say also EC because technically BD is also the hypotenuse for triangle ABD. Alright? Now if you have any questions about like rhombuses, rectangles and squares, bring it to your deep dive lesson. Alright, and then on to our last thing of the day, trapezoids. So essentially a trapezoid is a quadrilateral with exactly one pair of parallel sides. Alright, so normally also with trapezoids we will call the parallel sides the base. So we have base A and base B, and then this down here, which we would call either the height or altitude. They're the same thing. Alright, so we will need this in a bit when we're trying to find the area. Okay, anyways, so there are two types of trapezoid. So we have a regular trapezoid, and then we have an isosceles trapezoid. Now we say that this is an isosceles trapezoid because as you can see, these two angles here would be identical. Same thing for here, these two angles would actually also be identical. Alright, so that's why this is an isosceles trapezoid, because of the congruent angles. Alright, now the median length, so this thing is the median, remember, is the average of the two base lengths. So how we would find that is M would equal to A plus B divided by 2. So we would use this formula to find the median length. Alright, now again, let's look. The base angles of an isosceles trapezoid are congruent, like I said here, right? They're congruent. And the median of a trapezoid is A, parallel to the bases. See, this is parallel to these two bases, and has a length equal to the average of the lengths of the bases, which is why we use the formula for this. Alright? And we'll actually see a little bit about how we would play around with this information during our deep dive lesson. Alright? So, if you have any questions about quadrilaterals, send me a message, email, or bring it to your deep dive lesson. Alright? Thanks for tuning in and have a good rest of your day.